the point? So, yeah, that's a big thing.
Lorena.
In the case of the life science department, we have also problems with the funding because the main goal of life science is to do a publication. And it has done something bad with us because there are a lot of publications that cannot be reproduced because the data is not available. And the council is taking part in that to make it possible to reproduce everything wherever you are and to make the data available for all the people, not only for the research centers and in private investigations, but also to the public. So I think that in a very few time, we would appreciate a change here. And maybe there are more funding because there is no competition on the same study or in the same research.
Thank you. Have we got another question? No? Okay, well, I have a follow-on from that one. All of you mentioned writing proposals there, and writing grant proposals, getting funding. I read an interesting article this morning that was giving some comments given by a Nobel laureate last week about how he was very concerned that in academia we are spending too much time writing grant proposals that we don't do any science anymore. Do you think that applies to high-performance computing as well, which is very reliant on government funding because it's always the bleeding edge of science? Does anybody want to go first, Jasmine?
Absolutely. Most of the time, well, in HPC, you are trying to get a model done, you send it, and in the meantime, you're writing a proposal for the results of the next model that you're sending, or for those results that you're actually trying to get, or for the thing that you're thinking for tomorrow. It becomes really complicated to actually do the project that you are actually supposed to be working on at that moment without thinking that you need to apply next day for another project. So you have to be trying to think how you link a bit some of these results to put a bit of more of preliminary results for the next project that you're writing, and it becomes a big nightmare. I mean, I've been told that's your job as a scientist. I wonder if there's a better way to do those things, because then you spend all your time thinking about what to do next, and you cannot focus on what you're doing at the moment. And then that impacts your results. And then you're trying to also write the paper to try to get something, to get more funding. So it's tough because competition is really tough. So there must be some kind of balance around that, which we haven't found clearly, which is actually becoming more and more difficult now, because how much money is given is being reduced. There are more scientists. Then you have to be fighting harder for things, and then you have no time to develop new ideas or to actually work on them. So it's a bit of a pity, because a lot of resources and a lot of actual good ideas are being thrown away.
Yeah. I mean, Rosa, as the most senior person here, do you think this is something that has happened before and went away and then has come back in, or do you think it's a real difference this time that we're now spending so much time writing grant proposals?
I would say yes, that it's been increasing during the last 10 years. So every time we are writing more proposals. But also, it does not worry me that much, the proposals, but also at the European level, all the bureaucracy related with the European projects, which writing deliverables and the way reviews are organized and the way they ask for impact business models, things that sometimes, I mean, it's just a research project. Do I really have to have a business model at the end? So, and some reviewers are really keen of this type of things, no? And so you are then doing a lot of things besides writing proposals that are not that much what is the actual focus of your research, no? And yeah, this bothers me quite a lot.
Okay. Lorena, do you want to add anything?
I totally agree with them, but I also want to say something positive in that case.
It's not all doom and gloom. It is not. Sorry.
Is that more and more there are also collaborations between different institutes and different researchers. So if there is no competition for a proposal or for a publication, we can collaborate and we can do some projects easily, or maybe with not so nervous to have a competitor there. So this would be a possible positive point in that case.
Yeah, and I think just to follow on from that, that the upside to this is definitely that the interdisciplinary nature of grant proposals is now really beneficial, and that's benefiting high-performance computing because by nature we are very interdisciplinary. So it's not all doom and gloom. But it is a real aspect of what it means to work in high-performance computing. But going on to something slightly more positive, because at the end of the day, all of us work in high-performance computing because we love it, so it clearly can't be that terrible, right? Even if we have to write grant proposals. What got you going in HPC? Did you have a mentor or somebody that just inspired you, or was it entirely accidental to get going in HPC? Does anybody want to start, or should I just pick on somebody? Do you want to go first then, Jasmine?
Okay, for me, as I mentioned before, it was a bit accidental. I wasn't really focusing on HPC. I started working at BSc because actually a friend recommended me here. I didn't know BSc at that time, and they were looking for someone on biomechanics. So I just took the chance. I think it was a very good idea. And I think that it allows you, like I said before, it just allowed me to try to push the limits on ideas that I always had. So HPC just came like that, and it's good. So I would totally recommend HPC careers in that sense. But yeah, it just happened. That's it.
Anybody else want to, particularly I'm interested in if you've had a mentor at any point that really helped you galvanize towards a career in where you currently are, whether you call it HPC or not.
Well, when I did my postdoc, I did a postdoc at the University of California in San Diego. I started working on electromechanic models of the heart. And at that point, I was trying to implement, there I was working with Professor Andrew McCulloch. He was a big guy on these kinds of models. And I wanted to start implementing really highly detailed electrophysiology models to test about cell heterogeneity in the heart. And we were working there with their supercomputing center. And given how we were using the code and the parallelization that we were using and all of the methods, it was very difficult to try to run the models that I wanted there. So for that, I told my boss that I couldn't really do that with what we had. So he went on to buy a big memory node to be able to assemble all of the model. And that was the first time I actually got in touch with HPC. You know, you want to run this really big detailed model and you cannot do it. I had the luck that there, you have the issue and they just buy it and solve it for you. And after that, that is when I realized that the actual power of the HPC, that although you might have good ideas, but if you do not have the tools to do them, there's not much you can do. So I think that scared me a bit more towards the HPC and computational side.
Mm-hmm.
Yeah.
Lorena, have you had an inspiring mentor that encouraged you to step up to HPC?
Well, during my academic and working life, I have had a lot of mentors that have taught me how to use technologies in order to solve the problems from different backgrounds, as mathematics, statistics, web developing, and also financial data analysis. So I think that the most important thing is that not to think that you have that you possess all the truth, that you possess all the knowledge, and to try to learn from everybody that surrounds you. And now, for example, I have the highest mentors with my colleagues in my department, the computational genomics group, and also the life science people, who are always ready to help you and in everything they can. So I'm surrounded of mentors in my life.
Thank you. Rosa, do you have anything to add? And then we'll take another audience question.
Well, it's an old story, but maybe it's useful to share. So I finished my PhD studies when I was still at the group at the university. So this was before BSc was created, but it has to do with how I fell into parallelism and HPC and so on. And after my PhD, 2 years later, I had twins. So having twins make it difficult to continue research, to be honest. And then for a period, I was not doing much research. I was doing more management of teaching in the department. But after, when my kids started to grow a bit, after 2 or 3 years, I had the great opportunity to be involved in the HPC group, led by Jesus Labarta, my current director at the computer science department at BSc. No? So I consider him and also the associate director there, Eduard Aiguade, as my mentors. Although the figure of mentor in Spain doesn't exist that way, but I can think that they have been like not only my bosses, but also like helping me a lot to be able to evolve this career, no? Because to be honest, at that time when I had the children, I thought that maybe I will stop doing any research, because at that time I could not have time and my brain was not working properly. And this may happen to you as well, but don't get disappointed, don't think that this is the end, and the children grown up, and later you continue doing research, doing great things. So, and it's not only if they enable you to work or not. At night, the children is there and it's crying at night. So, and not one day after another. So, and this happens, okay? But don't. If you have your idea of doing a research career, don't give up, okay? Continue, but because opportunities arise.
Thank you. I will take an audience question. I had one over here. Let me get the microphone. Thank you.
Hi, I just want to ask a really simple question. At the very start, you said, what makes you HPC? And the answer was universally, well, we kind of fell into it. How do we encourage more students at undergraduate level to realize what they're doing can bring them into this area?
Is anybody? Rosa, go for it.
Okay, yeah, this is very good actually, because I finished my computer science studies without any knowledge of parallelism or of supercomputers. Right now, for example, at our faculty, the Facultad Informática Barcelona, we teach parallelism at a very early level, at third level. We have a subject called parallelism, and later on they have other subjects also that they can choose, and especially in the master. In the master, they can have very specific topics on this. Okay, so In our case, now it's in the undergraduate and on the master program. But this is for computer scientists, of course. In other areas, I don't know exactly.
Anybody else want to tackle that Lorena?
I think that to encourage people to get into HPC, it's important to define them that they have so different ranges in which get part in HPC, and it is not only to be a strong computer scientist which optimize and parallelize and does everything with so much detail, but also to try to be more horizontal and to apply the scripts in everything that can solve an actual problem.
Thank you. Jasmine?
I think nowadays we're more used to technology. I think we should be able to I don't know, teach students. Well, now they know that they can apply with different apps. They can apply technology in their own phone to very interesting questions. With an app, you can see the weather in all of the world. With you can, I don't know, there are also these that track your ECG and things like that. I think I do not have a real answer for that, but I think that now these generations are actually more open to applying technology in all different ways, and I think HPC is clearly embedded there. I don't know how you can tell them, like, well, this can easily lead you back to an HPC career and you can do amazing things. I don't know if it's showcasing more HPC results from applying different I don't know, different kinds of science with HPC. I don't know if well, I remember, sorry, years ago, I was using a Sony mobile, and they were sending an app so that you could share your computer time or your mobile time while it was charging at night. And so that they were trying to solve this for a gene for cancer, breast cancer research. And those kinds of things, I think, I mean, they just go straight to people to see that they can actually use HPC, or they're using it while they're sleeping. And I think that makes a big case for, you know, this is the application, and you can do this and a lot more. So I think it's not going that bad, but if we can showcase more of those ideas to the students, I think it's just bound to happen.
Thank you. That was particularly this last question, I think, and that is the last question. I will let everything else carry on now, but that really epitomizes what part of the challenges, but also part of what is exciting about HPC, which is actually, if we can tell everybody that HPC is everything that's at the leading edge of computing and technology, then we can get that out there. Because as you've highlighted so well this afternoon, actually, for example, Jasmine, from what you described about what you do every day, is that you are using computer science to solve equations in physics with a bit of maths and some chemistry to actually get answers for biology. And that's just one small part of high-performance computing, and immediately you've got the whole of STEM right there. And really, high-performance computing is about every single thing, everything we're curious. If we can get that message out there, then hopefully it's not too much of a step to convince people that high-performance computing is an area that we should be interested in. I would like to take this opportunity to thank the panelists very much for coming along and sharing their ideas. I don't know if you'll be hanging around, but there is a pizza party later. If you are, I'm sure they would be happy to talk to you about their jobs, about their day life. And I hope you've been inspired today to learn more about high-performance computing and to go out there. And crucially, if there's one thing you do, if you become somebody who uses high-performance computing, is please tell people that you do that. I remember talking to Alison a couple of years ago when Prace put together the magazine she described about women who do science in high-performance computing, and how some of those people, when we approached them, were like, I don't do high-performance computing. Oh, you need to speak to my colleague. They did do high-performance computing, and I think sometimes we don't own the title because we don't feel like we do it. We do everything, and actually, if we're to encourage other people that what we do is not scary, we need to stop automatically saying, oh, I don't do that, I do something else. Because if somebody thinks you're doing it, you probably are. So, on that note, I will finish. Thank you very much. And I will hand over to Rianne for the closing.
Now I would like to, after thanking very much to the panelists, Anthony, I would like to invite Maria to give a little information about the video that we're going to watch now.
Good evening, everyone. So firstly, let me thank you, the organization, for giving us the opportunity to show you our initiative. Our initiative is a theater play for young people from 8 to 14 years old, and is created to show a female model in science, technology, and engineering. And also it is performed by 5 actual female scientists from the University of Seville. Okay, this is the video that you are about watching is an abstract, because the original play takes almost 1 hour. Okay, so here we have only 10 minutes. So this video takes some pieces from the play. Okay, from the different old scientists and the present one, the current one. Okay. So if you need more detail, or if you wish to add something, you can do it at the end. Okay, I will be in the poster. This is the poster number 74. Okay, if you want to ask me something, I will there. Okay, so enjoy the video, and thank you.
Mi nombre es Hipatia y yo nací en Alejandría, hace más de 1660 años. He venido a hablaros de mi vida. Veréis, cuando yo nací, Alejandría era una ciudad fascinante. Mi padre, Teón, era el que dirigía la biblioteca. Que como a mí me gustaba tanto leer, pensaron que sería buena idea que yo me educase allí, en la biblioteca, con mi padre, aprendiendo y ayudando a otros a aprender. Y a eso dediqué toda mi vida, que descubrí cosas súper interesantes. Hice inventos y muchísimas más cosas que ahora os voy a contar. ¡Pantalla! ¿Me puedes poner una foto de mí? ¡Ay! Si ni lo he dicho y ya lo ha puesto. Si pasan los años y alguien inventa algo. ¡Hasta luego!
Es que veréis, soy Ada, pero Ada sin H. Porque por aquel entonces, aunque os parezca mentira, los cálculos se hacían en el mundo que escribió un programa para un ordenador. Soy muy polifacética, me gusta todo y además, como veis, antes muerta que sencilla. ¡Hasta luego!
Bueno, yo soy Maria Sklodowska y nací en Polonia hace 160 años. Y tanto nos atrajimos Pierre y yo que no nos separamos nunca más. Pero me tuve que ir a Francia porque en mi época a las mujeres no nos dejaban estudiar en casi ningún país. ¿Sabéis cómo hicimos nuestro viaje de novios? Exactamente. El dinero que nos regalaron por la boda lo gastamos en comprarnos unas bicicletas. Yo soy famosa porque mi hija Eva, que escribía muy bien, escribió una preciosa historia sobre mí.
Una científica tiene mucho más emoción y una vida mucho más llena de muchas más cosas y más apasionante que la mejor de las princesas.
Adiós.
Yo soy Rosalind Franklin, mundialmente conocida por hacer ¿qué? Una foto. No, esa foto no.
Pues Rosalind Franklin fue una persona que, a pesar de todos los problemas que tenía por ser mujer, simplemente, porque lo único malo que había hecho es ser mujer, pues desarrolló una labor investigadora muy, muy fuerte, ¿no?
En realidad hice un montón de cosas mucho más importantes y más interesantes para la ciencia que la mayoría de la gente no lo conoce.
¿No? Lo triste, como cuenta mi personaje, es que solo se le recuerda por la foto 51, ¿no? Cuando, por ejemplo, en el área de los estudios del carbón y del grafito tuvo unos trabajos impresionantes que todavía se siguen referenciando.
Y yo dije, pues voy a investigar en algo que pueda ayudar a mi país en la guerra. Y dije, me puse a pensar yo y dije, voy a estudiar el carbón. ¿Qué pasa? ¿Que no os gusta el carbón a vosotros? En fin, desgraciadamente, un cáncer me separó muy, muy temprano de mi microscopio. Nunca me separé de la ciencia y me hicieron muy feliz todos mis descubrimientos, los grandes y los pequeñitos.
Hola chicos, ¿qué tal? ¿Cómo me veis? Elegante, ¿verdad? Pues yo con esta Pamela no veo un pimiento, así que me la voy a quitar. Soy Hedy Lamarr. Nací en Viena el 9 de noviembre de 1914.
Ella desarrolló un sistema de transmisión secreto que le llamaron. Y bueno, para eso le ayudó un amigo que era compositor y se llamaba George Antheil. Y bueno, realizaron un invento, hicieron una patente con la idea de que el gobierno americano lo usara en la Segunda Guerra Mundial.
Imaginaos que queréis hablar con un amigo, una amiga sin que nadie se entere de lo que habláis. Si habláis todo el tiempo castellano, os van a entender. Imaginaos que os ponéis de acuerdo para hablar 5 segundos en castellano, 7 segundos en inglés, 8 segundos en ruso. A la persona que está escuchando no le da tiempo de cambiar el diccionario y entender lo que habláis. Pues algo así fue lo que inventamos mi amigo George y yo. Siempre he tenido dos pasiones: la ingeniería, esto de los inventos, y el cine. Creo que me ha entrado un WhatsApp. He quedado con una amiga matemática, me tengo que ir. Bye, bye.
Hola.
Buenos días y gracias por venir. Nosotras somos las 5 científicas que hemos interpretado a las 5 científicas del pasado que acabáis de conocer. Luego somos 5 científicas del presente. Y para que veáis cómo han cambiado las cosas desde que estudiaba Hipatia, Hedy o yo misma, digo ya todo, os vamos a contar un poco cómo es la vida de una científica hoy en día para que os animéis.
Buenos días, yo me llamo Isabel y soy matemática también, como Hipatia, mi personaje, pero yo no me dedico a estudiar cosas de la órbita de los planetas, sino que yo me dedico a hacer geometría. Yo estudio superficies que sean especiales.
Yo fui la primera mujer española a la que invitaron a dar una conferencia en el congreso más importante que tenemos los matemáticos a nivel mundial. Tenemos unos congresos que se hacen cada 4 años, que es donde damos nuestros premios que se llaman la medalla Phil, que es como nuestro Nobel de las matemáticas. Entonces eso se hace cada 4 años e invitan a una serie de matemáticos a dar una conferencia sobre su área de investigación. Y el 2010 fue cuando nos invitaron a mi compañero Pablo y a mí, nos invitaron a dar una de esas conferencias y resultó que yo era la primera mujer española a la que invitaban.
Sí. Bueno, yo soy María José, también soy matemática como Isa. y como Clara, que la conoceréis después. Y bueno, a mí me gustaba en realidad toda la ciencia. Cuando estaba en el instituto yo no sabía